Kusu. So if you don't find okay. So STEVIEKUSU or blockchain now. All right, so don't be shy. Okay, so blockchain, let me give you the common definition of blockchain is it is a decentralized ledger that permits peer-to-peer interaction in a secure and decentralized manner. But that's very boring. So blockchain, in my own terms, class of everybody in this space interacting with everybody at the same time independently, but just between me and you. So we're all in this space, and then I'm talking to you in a very separate manner, or just isolatedly. He's also talking to this guy. Like we're all having an interaction in a space, but just between just between people of just like similar interests. All of us have the same interests. All of us want to achieve the same goal at the end of the day. So blockchain is the interaction or the exchange of information or data within two parties that is cryptographically encrypted. Okay? So there is promised security, there is transparency because you can always fetch data on the blockchain at any time, whether it is private or public. Okay? So there are two types of blockchain then. There is one that is public and then one that is private. Okay, so entering this school, because we were not students, it took us a while. We had to confirm from Cyril, like the security guy had to talk to Cyril before we were permitted into the school. Though it's a public space, right? But it is only granted access to certain people. Do you understand? So what if you go to Wuse2 market? All you need to do is just pay that 200, whether you are carrying a bomb on you or not. Just pay 200 by the gate and you walk in. You walk in without anybody checking you, without anybody trying to verify your identity or why you are there. So blockchain functions in these two perspectives. You have the private and then you have the public. The public is for everybody. The private, you need certain permission. Please feel free to just stop me if we need to ask questions, right? So I'm here to talk to you about Algorand. Algorand is a Web3 solution. Bitcoin just came in to introduce the power of blockchain, the power of cryptocurrency, what you can actually achieve with blockchain. Then Ethereum said, no, let's not just talk about cryptocurrency, let's go beyond cryptocurrency. Can we begin to have people sign contracts? Can we begin to have people run transactions? And then the issue of smart contract came into play. So Ethereum now came and introduced what is called smart contract, just so people can be able to interact with the blockchain like you do on a daily. Then the transaction on Ethereum is very expensive. Can we step it up? Can we make it a lot more cheaper? So people kept building and stepping down this cost of transaction, making it more scalable. On Ethereum, you can have very limited number of transactions per second. On other blockchains, 3.0 blockchains, you can have 2,000, 1,500 transactions per second. On Algorand, you can have a whole lot, more than 1,000 transactions per second on Algorand. And then I just saw a tweet before I came here. Now the good news is, this guy was comparing Algorand to other blockchain protocol. On Algorand, you pay 0.001 algo per transaction. One algo, as of now, it's still less than $1. So it means you pay like 7 naira to perform a transaction that you would spend about 100,000 on Ethereum. Do you understand? So these things are getting cheaper, they are getting lighter, they are getting more interesting, and as we go every day, new innovations are coming up. So this tweet, the guy said he performed, on his wallet, he performed 5,000 transactions, like he sent in out crypto, or he was able to sign transactions. He was able to use Algorand's protocol 5,000 times. And the 5,000 times cost him a little below or a little above $5. I have done Ethereum's transaction just a few months ago. That was the last I did actually. Just to perform one transaction, I spent about 300 and something US dollars just for the transaction to pull through. That's one. So let's even say 300. So do 300 times 5,000. You know the result, right? So this guy is now saying Algorand has actually helped him to be able to do. So there are a lot of upgrades, a lot of innovations around Algorand. I was just informed that you want to do, what's that guy's name? Where's the guy? He has some NFTs to mint. And I just told him, okay, so imagine if he's going to mint the NFT on Ethereum. And then he has maybe 1,000 of those NFTs, those pieces of NFTs. And each of these transactions is going to cost maybe, let's even say $100. Do the math times 1,000. The $100 million was gone. So this questions the issue of security, right? So, but Algorand was able to fix the issue of security. It's very transparent, and then it's very, very scalable. I told you that you can perform 1,000+ transactions on Algorand per second. Do you understand? So that's the kind of thing that we're looking for. So going back to NFTs, and then going back to the advantages you can take in the blockchain ecosystem. Meanwhile, Seth is coming to just introduce you to what we do precisely on Algorand, how you can be able to get the best tech solution on Algorand, and how you can be able to even deploy your normal applications that you would want to build on Algorand. He's coming to just give you an introduction. Going forward, we intend to have a boot camp that we will not do rush. We will not come and talk in a haste. Okay? We'll take like 3 days if we have the time, and then we'll take you through how you can effectively do this thing. Who is interested already? Like you want a boot camp. Okay. So today is just going to be an introduction, and then Seth will introduce you to these dev tools and what you need to know about these dev tools. So going to NFTs. NFTs are just digital arts that you can mint and then sell them for your own. Justin Bieber just bought an NFT worth $445,000. I just saw it this morning. He bought it, I think, last week or thereabouts. It's one of the Bored Apes. Now, the Bored Apes are the most expensive NFTs you can ever think of. These guys just came with bored, actually looking, very funny looking apes, and they're selling them for good prices, like very, very good prices. I mean, would you want to just, for a digital art, would you want to spend $444,000 US for just a digital art that you can't do anything with it? I wouldn't spend that amount of money. Do you understand? Maybe if I have money to throw away on NFT, maybe I would spend 1,000, just maybe, if I have plenty money. But this guy is spending 444K. So there are NFTs that were sold for millions of dollars. Like, I mean, millions of dollars. So you are not off the track if you're thinking minting NFT, if you're thinking developing NFTs for yourself. It is the real thing. It is a trending thing right now in the blockchain space. And like I told you, to mint these things cheaper, and then to make them fly higher, you can mint them on Algorand. Algorand is stupidly cheap. Yes, it is very, very cheap. Okay? So you could just do a check on Algorand. You can follow them on Twitter. They have every day they are having new partnerships, they are having new things coming up and all of that. So it is a way to get started. Then also there is the next thing that is called Metaverse. Myself and Seth also, we're also on the thing. Somebody paid, he bought a piece of land.
The normal software development, mobile web and desktop applications. So for this discussion, I'm going to talk about how to actually build or deploy what you want to deploy on the Algorand network. Like Stephen said, Algorand is the whole blockchain itself, the blockchain technology itself, just like Ethereum, which has a smart contract called Solidity. On Algorand, Algorand has a smart contract called TIL. TIL stands for Transaction Execution Approval Language. So, and then they also provided us with SDKs that we can use. If you are familiar, for those of us that are familiar with programming, they have SDKs for Python, JavaScript, Golang, Java itself, C# and many other programming languages you can use. But then, and let me use Solidity for example on Ethereum. You can use Solidity to build what you want to do based on the smart contract layer, and then deploy it in your front end. For example, React. But then on the Algorand, the TIL smart contract is an approval language. You cannot perform transactions directly with TIL. It's basically a condition-based smart contract. So you define what you want to do, and then you fetch it or consume it using your SDK, which your preferred programming language, and then the transaction will perform. So what I'm going to basically do is, on Algorand, any one of you here can create a transaction. Okay, we know the banking system be a centralized system controlled by the banks and the government. For you now, for example, now you have to make a transfer using your bank app. You're limited to it, and then how many of us have built or have attempted building a payment processor? But then on the Algorand network, you can do that in less than 10 minutes. You can do that. You can build your own smart contract that you can use to transfer Algos. Algos is a native token for Algorand, just like we have Ethereum, Bitcoin, and the other cryptocurrencies we have. On the Algorand, the native token is called Algo. You can build your own smart contract that can transfer Algos from one person to another, from your own account, for example, to any other person. We have what we call group transactions, which is also known as atomic transactions. So with atomic transactions, okay, for example now, you're an employee, you have a whole bunch of employers you want to pay, and then you want to start sending them Algos or the native token one by one individually. With atomic transaction, it basically groups every transaction as one, and then processes the transaction at once. So like, so long as the conditions are met, that's if you have the amount of Algos that can cover for all the account addresses you want to fund. And on the blockchain, we don't use, like you have seen this, like that security is there, the transparency is there. If you make a transaction, there is what we call transaction ID. So now you can look up that transaction ID and then see who the sender is, the amount, the balance of that sender, that's how much that sender has. You can see the receiver, you can also see the balance that receiver has, and then the amount that was sent to the receiver address. No names are being used, you can't use your personal names, just account addresses. Now I don't know if those at the back can see, this just is demo to create an account for Algorand. So on the Algorand network, we have what we call testnet, there is betternet, and there is actually working. And then let's say now you want to deploy it to maybe a limited amount of users for them to test it out. Then you cannot deploy it on betternet for testers to test it for you. That's not you now testing it, other people can also test it. When everything is done, you can then release it on the mainnet. Now, mainnet has to do with actual, like real money, that's real outputs. But then on the testnet and metanet, we're talking about fake outputs, or should I say, dummy tokens you can use. But with this code right here, you can actually create your own account address on the Algorand network. I didn't have time to maybe test some things out. And then, aside from creating an account address, like I mentioned, you can also build your own DApp that you can use to send transactions from one person to another. So let's just quickly, I won't give us through the code because I know some of us are not developers. I'll just run it and then you guys can see how it works in real time. So I'm going to use the JavaScript programming language. Okay, so on the Algorand network, after you create your account address, you are going to have your account address itself and then a private key. The account address is public key, it's called the public key, while the mnemonic key or seed phrase is called the private key. Now that seed phrase is very sensitive and important. Like, it's very important. Like, if you want to create one, you have to keep it secure. In fact, it's best to keep it offline, away from the internet. You can write it down or something. And because if someone has illegal access to your seed phrase, like, consider all your money gone. Like, because that person can use your seed phrase and then perform transactions. Actually, when you're doing dApps to send transactions, it's that seed phrase that you use to send the transaction. We didn't talk about blocks. Of course, blockchain, the word block and chains. We have people like a chain of blocks. Now just imagine a chain of blocks, and then each block is like a database, for example, that stores transaction history or details about the transaction. Like I said, if you perform the transaction, you can see the transaction ID, the transaction hash, the sender, the receiver, and balance, and all that. All those details are actually being stored on the block. So if you perform a transaction, your transaction, that's the details about the transaction, will go into a particular block, into a certain block, until that block is filled. And then, mind you, not all your transactions go to a particular single block. It's randomized. Your first transaction can be in one block, the second one can be in another block, which now talks about security, how secure it is. Because if someone tries to hack a particular, in fact, well, that will be for another. The whole security issue is quite complicated. Let me go to code in this. So this API key is actually gotten from PureStick. PureStick is a website that you can use. Just create an account and then you can get your PureStick API key. Now, this PureStick API key, and then of course I made mention of testnet, betanet, and mainnet. For this testing purpose, I'm going to use the testnet. That's why we have this base server. This is testnet.algorand.api.purestick. We're using the PureStick version, so this PS2 is in here. And then to set up a transaction, you need these parameters: the token, the base server, and the port. Port is optional. So, like I said, you can see this mnemonic over here. This is how a mnemonic actually looks like. It's a whole bunch of words gathered together. There are 25 of them. We decided to come, there are 25 of them. And this is how a mnemonic looks like. So if you want to create something or you want to create an account, make sure you keep your mnemonic key safe and secure. So now with your mnemonic key, you can do a whole bunch of things with it. You can get, let's say now you've forgotten your account address. And of course, you're going to want to keep your mnemonic key secure. You can use your mnemonic key to get your account address back. But you can't use your account address to get your mnemonic because the account address is a public key that anybody can see on the blockchain. So, but you can't use that to get your mnemonic key. But you can use the mnemonic key to get your account address back. So I'm using the Algorand SDK with JavaScript. This using the SDK, Algorand SDK, the mnemonic to security key, and then passing in the mnemonic key inside of the contract. And then console.log, of course, to print out what the recovered account is. So now, to perform the transaction, you need some details or parameters you need to pass in. You can see from now, that recovered account address was gotten from the mnemonic key. Like I'm recovering the account address using the mnemonic key. So that's the first parameter I'm passing in here. And then this is the receiver. We have from That's from the money sender. That's the person who is sending out those. And then 2 is the receiver. This is how an account address looks like. It's just the whole character of words as letters and numbers together. What transaction fee? Like you mentioned, the transaction fee on our network is 0.01 hours, which is less than our payment is about $0.9. Yeah. Which is then the next specified amount you want to say. Now, when using estimates, we have on the realized that okay, before, if you want to send out to someone, the amount you are going to send must be more than the transaction fee. So you can't send 0.0001 outgoes when the transaction fee is 0.001 outgoes. So that's like a condition, but I don't know if it changed because it worked this morning. And then there's what we call first round, last round, Genesis ID and Genesis hash. All these are also parameters that are going to determine the round of which your transaction is going to be. That determines the block that your transaction details are going to be in. So that's what we have. The first round, last round, Genesis ID, Genesis hash. And then you can add a note. A note is optional. That's the reason why you're sending out. That's optional if you want to. If you don't want to, you can move that out. So that's it about declaring all the transaction parameters. These are all the parameters we need to perform the transaction. The next up, like I said, till transaction execution approval language. You can't use it to perform transactions itself. You can only approve or reject transactions if the conditions are met. Now, for instance, what I talked about, like you can't send 0.001 outgoes, or you can't send an amount that is less than the transaction till actually checks for that. So, and then in a situation whereby you don't even have outgoes at all and you want to send outgoes, the transaction won't work till also cross-checks that. So before you do anything, before you even sign a transaction, before you send a transaction, you have to sign a transaction. So that's what this next page is all about, this sign transaction here. After a signed transaction, and then we're passing with the transaction parameters that we declare, which is TXN for transaction. And then the person or the account address that is signing that transaction. So if I'm what I'm going to do here, I'm going to paste in the transaction ID and then look up what we have.